Hi everyone, welcome to your section 4.1 notes. I apologize that I'm not on screen. I'm having some technical difficulties with my recording software, so this is what we're going to get, and this is what we'll get through with. So we started section 4.1 before Thanksgiving break. If you guys remember, we did a Desmos activity where you had to sort triangles by isosceles, scalene, and equilateral. Which is the first part of section 4.1 here, so we should kind of get back into that, which will be good. And then we talked about how all three angles inside of a triangle should add up to 180 degrees, which is our interior angle theorem. So those are two components out of the three that are covered in section 4.1. The only other thing that we have not touched on is what we call the exterior angle theorem, which really isn't too complicated. Okay, so here we go. 4.1, classifying triangles. Please fill these into your notes. We have three different ways to classify triangles by its sides. A scalene triangle means that our triangle has no congruent angles. So I don't know if you want to write in the box there that there are 0 congruent angles. Would be my shorthand notation if it were me, or you can write it out if you want. Isosceles, we know that we are going to have zero congruent angles, 0 congruent sides. We're not in angles yet. 0 congruent sides. Isosceles, we have 2 congruent sides. And equilateral, we have 3 congruent sides. So all of the sides are the same, which makes it equilateral. And then we can classify a triangle by its angles. If all of the angles are acute, then we call it an acute triangle. So you would have 3 acute angles. If you have a right triangle, that means that you would have 1 right angle, which means that the other would have to be acute, right? And obtuse means that you would have 1 obtuse angle. There's no way to have it have 2 obtuse, right? Because then that would be more than 180 degrees. And if you have all 3 congruent angles, then we call it equiangular. And if it's equiangular, then I know that all of these angles would have to be 60 degrees, right? Because 60 plus 60 plus 60 makes 180 degrees. Okay, so you're going to have to do problems where you're going to ask to classify a triangle, and you're going to pick one of the names for sides and one by the angles. So in number 1, focusing on the sides, notice I have 2 tick marks right here and right here. So that would mean that I have 2 congruent sides, which, what do we call something with 2 congruent sides? That is isosceles. And we have a box here, which is telling me that I have a 90-degree angle, which means we would have a isosceles right triangle. For number 2, I've got 3 tick marks, so we've got 3 congruent sides. I guess I should probably have circled this, so that would be your final answer, which makes us equilateral. Technically, when we're equilateral, the angles will also be congruent, but we're not shown that. So we have 3 acute angles. I don't have a box in there, and neither of those angles look like they're more than 90 degrees. So I would call this equilateral acute. Or if you said equilateral equiangular, you would also be correct. Number 3, I have 0 congruent tick marks. So that makes it scalene. And then if I look at all my angles, this looks like an acute angle. This one down here looks acute, but look at this top one right here. This one clearly looks bigger than 90 degrees. So I'm going to call that obtuse. So my classification is scalene obtuse. Would be my final answer there. Okay, so classifying triangles, make sure you've got that. I know this is not in your notes, so let's just quickly do a quick practice, see if you got it. I have all 3 sides are the same, 8.6, 8.6, 8.6. We have equilateral. All 3 angles are 60, 60, 60, so they're all congruent. So that would be equilateral and equiangular. Here, all my sides are different. I have a 6.1, a 7.4, and an 8.7, so that would be scalene. All my angles are less than 90 degrees, so scalene acute. For this one, we've got all my sides different, so scalene. I have one 90-degree angle, so scalene right, or right scalene. You can say it in any order. For my sides here, I have two 2.5, so I've got two sets of congruent sides. So that would be isosceles. And then look at that 128 degrees, which would make it obtuse. For this one, you have two congruent sides, so isosceles. And all your angles are less than 90, so isosceles acute. Here we have, again, two congruent sides, so isosceles, and I have a right angle at the top, so isosceles right, or right isosceles. Here I have no congruent sides, so scalene, and that angle at the top is clearly looking more than 90 degrees, so that would be obtuse. Here we have two congruent sides, so isosceles. I only have two congruent angles, which is not enough for it to be equiangular, so we'll just say acute, because all those angles look like they're less than 90 degrees. Here we have scalene, no congruent sides, one right angle, so scalene right. Okay. All right, so that gets us into the triangle sum theorem. This is what we investigated in class on Tuesday before break, which tells us that the sum of the measures of the interior angles of a triangle is 180 degrees. So if I had to find the missing third angle here, right? You guys remember what we were doing yesterday. Now I'm going to just practice writing out the equation, so when we get to the algebra part, it's a little bit easier. So we would do 25 plus 120 plus x equals 180. Make sure that it's clearly 1, 2, 3 angles being added together when you equal it to 180 degrees. So 125 plus 120 is 145 plus x is equal to 180. Subtracting 145 from both sides gets us x is equal to 35. Now, could you have gotten there by just subtracting on your calculator? Yes. But get in the habit of writing out the work, please. All right, so now we have some algebra involved. So again, we are adding 3 angles together. So you need to make sure that you need to remember that you have 3 angles. So whether you do this, 1 plus 2 plus 3, so you remember that it's 1, 2, 3 angles that add up to 180 degrees. Well, what's the first angle? I don't know, I'm going to make that one 90. My second one could be 2x. My third one could be x minus 6. So combining those like terms, 2x plus 1x is 3x. 90 minus 6 is 84 equals 180. Subtracting 84 from both sides gets us 3x is equal to, what is that, 96? Dividing by 3 on both sides gets us x is equal to 32. Solve for x, so I am done. Okay, so get in the habit of writing out that equation each time. First angle plus second angle plus third angle equals 180 degrees. Make sure that it's all 3. All right, so this one gets a little bit more complicated. We need to find x, y, and z. We've got 2 different triangles happening. So let's focus first on this blue one that I just highlighted. So I've got 3 angles. We know that the first angle is 65, a second angle is 39, the third angle is x, and that's going to be equal to 180 degrees. So combining your like terms there, 65 plus 39 is 104 plus x equals 180. Subtracting that from 180 gets us 76. So minus 104 minus 104. X is equal to 76. So we got our x. So I'm going to substitute that in place here. So x is 76. Now, look at the relationship between x and y. Do you see how they make a linear pair? Together they make this straight line. So that means they're supplementary. What does supplementary mean? So these are supplementary, a linear pair, which tells me that they should add together to equal 180 degrees. So 180 minus 76 should be 104, right? So that's not x. I should have made this y, sorry. 76 plus y equals 180. So y is equal to 104. Okay, so now I'm going to put that back into my diagram. So x was 76, y is 104 degrees. So now focus on the triangle on the right. You have 2 out of the 3 angles. So first angle is 104. The second one given to us is 21 plus z is equal to 180. So 104 plus 21 is 125 plus z equals 180. Subtracting 180 or 125 from both sides gets us z is equal to 55. Okay, so now do you notice, maybe you do or you do not, let's just kind of look at this diagram here for a second, get rid of the blue. Alright, so this is 104, this was 55, not that 55 really matters. If we focused on this blue triangle over here, and focus on this angle right here where I'm pointing to 104, what do you get when you add 65 plus 39? You get 104. And notice how that 104 is an exterior angle of the other interior angle of that triangle. Let's see if it works on the other side. So focus on this triangle. Notice here I have 21. Oh, and we did say z was 55, so let me bring that back in. And now look at your exterior angle here. Is 55 plus 21 76? Yes, it is. So this gets us into what we call the exterior angle theorem. And the exterior angle theorem says that the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. So pause me if you need to get that written down. So what does that mean? So if we have our triangle, right, here's my triangle. Here's angle 1, here's angle 2, here's angle 3. If I put an exterior angle adjacent, so next to angle 4, or sorry, next to angle 3 and make that angle 4, then this is the exterior angle. 1 and 2 would be your non-adjacent interior angles, right? Because they're not next to the 4. There's 3 interior angles. Those are 1, 2, and 3. 3 is the interior angle that is right next to 4. So 1 and 2 would be the non-adjacent interior angles. So what this tells me is that the measure of angle 4 would be equal to the measure of angle 1 plus the measure of angle 2. So all I would need to do is add them together. Now the only time that this really is important is when we have algebraic expressions in there and we couldn't just find 3 and then take the supplement of it. So you can easily do it that way. Like in these first two, you probably do it that way, but when we get to the algebra, it gets a little bit more complicated. Okay, so here we need to find the missing angle. So let's first do the exterior angle theorem. So here's my exterior angle at 1. These are your 2 non-adjacent angles. So the measure of angle 1 would be equal to 40 plus 30, which is 70. So the measure of angle 1 is equal to 70 degrees. Could I have gotten there? Yeah, because 40 plus 30 is 70. When I subtract that from 180 to get that third interior angle, I would get 110. And then what's the supplement of that to get over to 1? 70 degrees. So you could get there either way. But it's a little bit easier to do it with the exterior angle theorem. So here my exterior angle is 113. Here are my 2 non-adjacents. So my exterior angle of 113 is equal to the sum of the other 2 added together. I don't know the measure of angle 2. So subtracting 113 minus 70 gets us an answer of 43 is equal to the measure of angle 2. Could I have gotten there the long way? Sure. What's the supplement of 113 to find this interior angle right here? Well, 180 minus 113 180 minus 113 is 67, so this angle would be 67 up here. And then 67 plus 70 plus our unknown, 2, right, is 180. 67 plus 70 is 137, plus our unknown angle is equal to 180. Subtract that one from 180, gets us to the 43. So x is equal to 43. Okay, so you can get there the long way, but it's quicker if you remember the exterior angle theorem. So when you have algebraic ones like this, you will have to use the exterior angle theorem. So what does our exterior angle theorem tell us? The exterior angle is equal to these two to add it together. So there's your equation. 70 plus x is equal to 2x minus 5. Subtract x from both sides. 70 is equal to 1x minus 5. Adding 5 to both sides gets us 75 is equal to x, but we're not done. Look what it's asking for. The measure of angle JKM. So JKM is the exterior angle. So let's plug 75 in place of x. So 2 times 75, so doubling 75 is 150, right? Minus 5 is 145 degrees would be our final answer. Okay. All right, so I think that concludes your notes. We'll do some more practice with this as we move forward.